In this particular video, I am having three coils. These are called G coils which we use in our heater. This is in fact it's a 1000 watt heater coil, G coil. This is also 1000. All are identical. So this in this video I'll be showing you, because I have three sets of coil. The first one is the good one. This is brand new. I just bought yesterday, and so it is in good condition. And the second one, I told you, it's having two coils, the inner one and the outer one. The inner one is of much lower rating. It is of 400 watt, whereas the outer one is of 600 watt. So combined you get 400 plus 600, it's 1000 watt. And the third one is this inner coil of the third one is damaged, whereas the outer is still in good condition. But the question that you may ask is, how do you know whether the coil is damaged or is still is still good? That means you take a multimeter, you have to measure the resistance. I'll be telling you that the resistance of the inner coil, is having a resistance, in the range of 105 to 115, like that, the inner coil. So let me take this. You see this, this is a good one. Let me take the good one. In case of the good one, the middle, these two, this one, this is for the neutral, and this is for the phase. You take this is the outer coil. Okay, this is the outer coil. I mean, it is for the outer one. This is for the outer coil. How much resistance you are getting? The outer coil. So the outer coil you are getting 78 ohms. 78 ohm is the resistance of the outer coil. So it is like this. Let me take this measurement. It is having two coils. This coil, the outer coil, which is this, I have represented here, which is this, and the inner coil, this one, the inner in the middle, which is this inner coil. So in the outer coil, let me write here, outer coil, how much I got? Resistance of 78 ohm. I told you it will be in the value of 75 to 80 ohms, but I got this much value. Is still fine. So this is the resistance. It is 6. This outer coil is, the rating is 600 watt. How do I get 600 watt? The power rating, how do you calculate? Suppose you take P is equal to I square R. This is, right? I is the current, R is the resistance. And since you do not know the current value in this particular case, so instead of, in place of I, you put V by R square. So if you cancel the value of V, you'll get P square by R. And if you take the standard voltage rating of 240 volt AC by the value of resistance that you have just measured, 78 ohms, you use a calculator, you will get a value of approximately 600 watt. So this is the power rating of the outer coil. That's why most of the time, if in case you are cooking something and in all of a sudden your inner coil get burns or get damaged or got broken, in that case you can still use the outer coil, because of it is of much higher rating as compared to the inner coil, which is of 400 watt only. So this is what I have got. And how to measure the resistance of the outer coil? You take this of the inner coil. I've measured the resistance of the outer coil. Now for the inner coil is this one, this, and the outer terminal that is for the inner coil. You can see it is going there. It is actually for the inner coil. You should get approximately 100, and I told you that it is in the range of 105 to 115. So I'm getting 109 ohm, which is quite okay. So in the case of the inner coil, the resistance is the resistance which I have just measured, 109 ohms. So use again the power formula, V square by R, 240 square by 109 ohms. You will get approximately 400 watt. So the combined rating will be 1000 watt rating. This is the coil. So this is how you do the measurement. But in case of the second one, this second one is actually what happened to this coil is that the inner coil is broken, it's damaged, you can say. So in case of the inner coil, so you have to just measure the resistance of the inner coil. That means this is, which is in good condition, you should get some value. You should get some value. Yes, you are getting right, 107 ohms, which is okay. But the outer coil, since it is damaged, you should not get any value. It will be open. See this one, yeah, this is the one. See, you are not getting any value. One, that means it is not giving you any value. But in the case of the third one, which is the inner coil is damaged, whereas the outer coil is still okay. That means the inner coil you should not get any value. This and this, you should not get any value. Yes, you are not getting any value, whereas in the case of the outer coil, it should be showing you some resistance. No, this one, yeah, it is showing 78 ohms. So this is how you measure. If in case it is not giving you value, that means the coil is damaged. Okay, so this is how you measure the resistance, and also you test, whether the coil is okay or not. You might have also seen, in every heater you will see a rotating knob. This one, you have position numbering 0, 1, 2, 3. What are these basically? Inside I'll be showing you, and then it goes to the coil. Inside the connection is like this. You see that this is the incoming. I'm just showing you only the phase and the neutral. The earth is not shown here. So this is how it looks like. It will come to the neutral and then the phase. Now what happens when you put this knob in a position number 0? When you put in 0, then there is no connectivity between this neutral and this, and phase with these terminals also, there is no connection. So as such, when the knob is put in 0, that means the coil is not being powered. So there is no current flowing, there is no heating at all, because there is no supply as such. But what happened when you put in position number 1? The moment I put in number 1, still the coil will not be heated up, because of the fact that when you put in 1, only this is getting the connectivity. So if you look at this, the circuit is still not complete, right? The power will only go there, and the circuit is not complete. Unless you get a complete circuit, there is no current flowing, then the heating also will not take place. So your coil will not be heated up if you put in 1. Now what happened when you put in position number 2? When this knob is put in position number 2 like this, then this neutral and this will short. So this inner coil will, you see the part is now complete. You have at least one loop here, so this will get supply. So this 400 watt, the inner coil, that is this inner one, will be heated up. It will get supply. It will give you 400 watt. So that is not, maybe it is not that much of a heat that you will get. That is the position number 2. Now when you put in position number 3, this one, when you put in position number 3, then this will also short. This phase will also short with this. So in this case, the outer coil will also come in the circuit. So when it is put in position number 3, both the coils will be getting supply and will complete through this. That's why you will have the maximum power, that is 600 watt. So combined you are getting 1000. So when you put in 0, there is no supply at all. But when you put in 1, only this is getting connected. But when you put in position number 2, then this as well as this is also are connected. Then this will be in the picture. When you put in position number 3, both this and this will be connected, and the circuit will be complete. And this is how you get the power. You get the maximum power when it is placed or kept in the position number 3. So this is how. So now this is a heater which is having the damaged coil. The outer one is okay fine, but the inner coil is damaged. So I want to replace this with a new one which I just bought yesterday. So how do I do that? I'll be showing you now. So for that, you have to first take to the other side, and then open this knob. It's very easy. So you have to gently remove this and keep it nicely. So this is how it looks inside. So I will unscrew these.